In this video, I'm going to go over how to find an inverse function, how to prove that two functions are inverses of each other, and how to graph inverse functions. All right, so let's start with number one. It says find and graph the inverse of the function f of x is equal to 1/3 x plus 4. So part A, it says graph the function and its inverse. Okay, so I want to start out just using a table. So let's make a table, x, and then we have f of x. Since we have 1/3 as our slope and we have a 3 in the denominator, I'm going to use -3, 0, and 3 as my points. So what happens if you plug in -3? Well, we would get -1 plus 4 is 3. If I plug in 0, I get 4. And if I plug in 3, I get 3 times a third is 1, plus 4 is 5. So what I'm going to do is I'm going to graph this. So I get -3, 3, 0, 4, and 3, 5. So there is my graph of f of x. All right? Well, the inverse function, if we're just looking at a table of values here, the inverse, if it does exist, is going to be the reverse of the x and y coordinates. So all we have to do, and the symbol for the inverse is we put this -1 here. Now this is not a power, this is denoting the inverse, so that means f inverse x. So what we're going to do is we're just going to flip these coordinates around and then graph. All right, so we would get, now we would get 3, -3. We would get 4, 0. And we would get 5, 3. And then we would graph that. Now what's happening with the inverse function, so my black line is f of x and my red line is f inverse x. All right? Well, what's happening is that we have some symmetry. So the symmetry, because we reverse the x and y coordinate, we have a line that is similar, or sorry, we have graphs that are symmetric to the line y equals x. So we have this line of symmetry in here to graph our functions. All right, so let's go back to here. So f of x we know was the original function they gave us, 1/3 x plus 4. This is linear, so what's the domain? Okay, so the domain is all reals. The range is all reals. And in our inverse here, now how do we find the inverse function? Well, I'm going to go to part B and we're going to find this algebraically. So how do we find the inverse algebraically? So what we're going to do, instead of using f or x format, we're going to use y equals 1/3 x plus 4, because what we're going to do to find the inverse algebraically, we're going to swap the x and the y. So what we do is we switch the x and the y, and then we solve for y. Okay, so how would we solve for y here? Well, we would subtract 4 from both sides. So we would get x minus 4 equals 1/3 y. And then we would multiply both sides by 3. So we would get y equals 3 times x minus 4, and then the y would become our f inverse. So we've got, so this would be 3 times the quantity x minus 4, and we can test this out to see if this is true. If we plug in 4 here, we would get 0. If we plug in 5, we would get 3, so this does work. Okay, again, we're linear, so the domain is going to be all reals, and the range is going to be all reals. right? So that's in a basic problem where it's linear, how we would find, how would we would graph the inverse and how we would find the inverse algebraically. Now, how do you know two functions are inverses of each other? Well, how would we do that? Well, we want to use the definition of the inverse to prove that two functions are inverses of each other. So what you're doing is you're doing the composite function. Now, in this case here, f of x is going to be my original function, but I'm going to let f inverse x equal g of x. So what we want to do is we want to find the inverse. So if two functions are inverses of each other, the composite function is going to equal x when we do it both ways. So if we have the inverse on the inside or if we have the inverse on the outside, if these both come out equal to x, then that proves that the two functions are inverses of each other. All right, so let's try this with our example. Okay, so we had 1/3 x plus 4. So what I'm going to do is I'm going to do f of g of x. So remember now, g of x is equal to f inverse. So what I'm going to do is I'm going to take my 3 times x, 3 times the quantity x minus 4, and I'm going to plug it in for x. All right, so if we simplify this, the 3's would cancel, and I would get x minus 4 plus 4, which equals to x. So the first, this came out equal to x, so that's good. So now we want to do it the other way and see if we get x also. So now, going the other way, I'm going to start with the inverse, and I'm going to plug in my function. So I'm going to plug in 1/3 x plus 4 minus 4. And in this case here, this would equal 3 times 1/3 x because the 4's would, 4 minus 4 is 0. The 3's cancel. So in both ways, taking the composite function, I get x as my answer. So this proves using the definition that the two functions are inverses of each other.